Well, it's finally happened. Liquids has arrived in Cinema 4D, but are they any good? Let's dive in and see what these new fluid sims can do and find out if they're actually ready for real-world production workflows. Alright, so I've been testing these new liquid sims for the past 2 weeks now, and honestly, kind of shocked by what I discovered. And in this tutorial, I'm going to show you some real-world scenarios where these liquids either completely impressed me or totally let me down. And by the end, I hope you're going to know exactly how to use them, what settings to tweak, and what the current shortcomings of these liquid sims are. Now, if you want to follow along, be sure to download the project files. The link to them are in the description below. All right, so let's get setting up some liquids in Cinema 4D. So we have this very simple demo scene. And what I'm going to do is I'm going to go up to the simulate menu, and you can either grab a liquid fill emitter, which is going to fill a shape with liquid, a certain amount of particles of liquid, or you can just use a basic emitter. And that's what I'm going to do is just have a basic emitter. I'm going to change the shape to a circle. And this is going to emit particles in the Z direction. So I'm just going to rotate this so it is pointing downwards, and we'll move this up a little bit. So basically we're going to have like a water hose splashing water onto these objects here. Now, if I hit play, we're just going to have some particles doing its thing. They're not liquidy at all. And so what we're going to do to apply liquid properties to it is grab the liquefy particle modifier. And then what this does is in this constraints here, you can see that what this is doing is applying liquid properties to these particles, okay? Now, this isn't looking very exciting because we don't have a lot of particles getting generated. So what we're gonna do is go back into the basic emitter, and let's just crank this up to say like 5,000, okay? And we'll hit play, and you can see we have a lot more particles going. It looks pretty, there's a lot of gaps in there, so we can even crank that up even more. Let's say 8,000. We can also shrink down the emitter as well, and we should have a more solid stream of water. There we go. Now, we don't have any collisions just yet, and that's because we have to apply collider tags to the objects we want the particles to collide into. So we're going to select our plate and 2 disk objects, go to simulation tags, and go to collider. Now, you'll notice with the new simulation system, there are liquid collisions now. So you now have the volume option or just the surface. You can determine the collision side, and it's using voxels. Okay, so what you can do is really dial in a lot of these options here. Typically, you could, if you're just working with just solid surfaces, you can just go surface, but I'm going to keep this at volume. And if we hit play now, you can see, okay, now we have this liquid interacting and colliding with our objects in our scene. Now you're seeing this happy dance party of particles on the top here, and this is caused by there's too many particles with water properties colliding into each other, and they're kind of interacting and bouncing off and exploding off of each other, which is not what you want to do. So what we can do is in the liquefy, there's a feature or a setting just for taming that little dance party at the top here, and it's this ease in. And what this is going to do is allow the particles to kind of ease into these liquid properties over a certain amount of time and make it so none of these particles overlap and explode out. So if we up this to say 10 frames, another thing I'm going to do is just make this liquefy modifier a child of this particle group just to keep things organized, okay? Because you have multiple particle groups, you can have multiple types of liquid that collide with each other, and you can have them mixed together if they're in the same mixture ID here. So let's go and rewind, and that should solve the little dance party that was happening up there. So this is looking promising so far. We got liquids, and it only took a little bit of time to set up here. So what we're going to do at this point is let's try to make some realistic looking water. And so right now we don't have any type of meshing going on. So what we can do is go back into the simulate menu and grab a liquid mesh. And this is going to basically mesh any type of liquid particles in your scene. You can see there's a whole bunch of settings here that we can dial in and cover a little bit later. Now, what I want to tell you is this is basically like your VDB. So this is kind of meshing it with a marching cubes algorithm that's pretty standard for, liquid meshes. And you can see at this point, this is just looking kind of like Nickelodeon slime. Doesn't look all that realistic. It's looking very blobby. Now, here's rule number 1 of C4D particles is that it does not play with real world scale values very well. Now, let's just kind of talk about that. So we have this influence scale on the liquid mesh, and this controls kind of how far apart it's building that mesh and connecting the particles together. So the bigger this value, it's going to connect more of those particles together and have a more kind of blobby, solid kind of mesh. If we bring this low, this is going to make the connections much smaller, and you're going to see almost individual kind of like droplets. Now, what the surface offset does from that is grow or expand the offset of that surface. You can see that going on right there. And now the steps, it's interesting because VDBs are made of voxels, and voxels are like 3D pixels. And so the more dense and the smaller the voxels, the higher resolution. So this steps right here, the higher this number, the smaller the voxels and the higher resolution mesh that we have. So you can see we have a lot more detail in here, but this is still not looking all that great. Our particles, our water droplets are super, super big. And what is generating the size of the particles is if we hit Command or Control D and go into our scene-wide settings and go to liquids, you can see the default radius is set to 3 centimeters. Now that is a very massive water droplet. You would not want to get pelted by a 3 centimeter sized piece of water. And so this is what I'm saying, where these default values are much bigger than real world scale. And it's just kind of how you have to work with C4D liquids. What I recommend you do is dial in the liquids to whatever type of look that you want, bake it as an alembic, and then just scale that alembic file down in your scene and apply all the materials and all that kind of good stuff. It's probably something Cinema 4D or Maxon's gonna change. They always like to do that with these particle sims, is they adjust the value. So I wouldn't be surprised if you're following along and you might run into some values that I'm dialing in, it works perfectly, and you dial it in and it looks different. Probably because Maxon kind of tweaked those values. So that being said, let's go and let's bring this default radius down to like 2, okay? And we'll hit play again. And one thing to kind of keep in mind is if you want to speed up your sim, just turn off the liquid mesh there. And so now you'll see we'll have smaller water particles, and we're getting a little bit more detailed liquids here. So you'll also notice that we're having a lot of gaps in between there. So one way to fix that is, again, just upping the rate. So I'll put in 10,000. Another thing we can do is just make our emitter size a little bit smaller. You can see it's 66 centimeters. So again, we're not playing with real world scale here. If we get Bob the Figure Guy, you can see how small Bob the Figure Guy is. That's based off of a 6-foot human being. So you can just see how massive our scene is to make this kind of look like a nice looking sim. And so, okay, we got some splashing going on. This is looking somewhat good. Let's turn on that mesh. And you're still seeing this does not look great at all. This does not look realistic. We try to make these little blobs smaller. Another thing we can do is utilize these smoothing options here to try to smooth out some of those options. You'll see we're getting a little bit of janky stuff going on there, but you're seeing this still looks like GAC, okay? We can up the smooth strength here and kind of adjust the surface offset and influence scale. And one thing you don't want to do is bring up the smooth iterations too much, or it starts to get kind of sharp and pokey. And you don't want pokey water, because that hurts even more than 3 centimeter water droplets hitting your face. But you can see that this is looking very, let's just say, not so realistic. Now, here is the second rule of Cinema 4D particles at this point. They don't have sheeting. And I didn't say the other word, I meant sheeting, like water sheeting. And what that is basically the thin film or the thin layer of water that occurs in real life. Now, I found this awesome website that kind of describes what water sheeting is. And so what's going on right now in Cinema 4D is we got a little bit of this situation where we have all these particles and they're breaking up. But right here is an example of a particle liquid sim that has the water sheeting that connects all those little dots together and creates a more realistic liquid. And so you can kind of see, I'll leave the link to this in the description, but you can kind of see what's going on here. So this is what we have currently in Cinema 4D, and this is what it would look like if we had the sheeting option. And hopefully it's not too far off in the distant future that they add sheeting to the liquid simulations. But here you can see what this should look like. Looks a lot more realistic with that thin layer of water that's connecting all these particles together, okay? So you can see more options here of the thin sheeting, that thin layer there. And so that sheeting explains why we don't have that kind of realistic water simulation inside of Cinema 4D, just yet, okay? So you might be wondering, well, EJ, if it's not good at realistic water sims, what the heck is this liquid sim in Cinema 4D good for? And I will tell you that I think what the liquid sim at this moment in time can do very well is very thick, viscous type of fluids. And I would dare say that those kind of fluid simulations, those thick, kind of syrupy simulations, are very MoGraphy, which kind of fits the whole strength of Cinema 4D in general. So let me show you how you can kind of dial in some of those more viscousy, thick, syrupy, honey type liquid sims. So what we're gonna do is we're gonna go to our liquefy, because this is where all the magic happens as far as dialing in viscosity, surface tension. And so let's just kind of go back here, and I'm going to turn off the liquid mesh for now. Now, viscosity is basically what is going to prevent particles from flowing a lot more freely. So the higher this number, if I put in like a value of 5, the more this is going to look like kind of chocolate, and it's not going to want to flow as much. You can see how it's starting to stick together a little bit. Now, viscosity in tandem with surface tension is how you're going to get that nice kind of viscousy, thick liquid. So surface tension is how much those particles are going to stick together and not splash out as much. So you can see, if I pause the simulation by hitting the escape key, that we have a lot of particle splashing going on. So to rein that in, we're going to go back to our liquefy, and let's put like 2.5 in the surface tension there. And so this should make it so we don't have any of those particles kind of splashing out as much anymore. So here we go. We got, let me zoom out here a little bit. We've got this solid stream of particles, and it's looking a lot more viscous, and we don't have as much surface tension, so we're not getting that splashing. And with the combination of both, we're getting a lot more of like a, think of like maple syrupy type of sim here. Okay, so now as this is kind of going down here, you can see an issue that I've heard a lot of people running into. And let me just kind of zoom in to this area here. The one gotcha, and the one of the biggest issues I see people running into is this little popping and locking of all these particles. And if I turn off the liquid mesh here and hit play, you can see this is the result of all these particles just kind of dancing around the edges here. And this is driving people crazy. And what people aren't realizing is there's a whole separate bit of viscosity and surface tension options if I hit Command or Control D in the liquids tab here. Okay, so you might be wondering, this is what confused the heck out of me when I first started using liquids, is what's going on with the iterations, and then what's going on with these settings here. So this is the overall strength of the viscosity and the surface tension. But in the scene-wide settings, this controls the accuracy or the quality of those properties. And so what I've been told by Noseman at Maxon, he's really given me a lot of information about this stuff. What he told me is that what you want to do is up these viscosity iterations so you have the best kind of quality of these features, and then go in and dial in the strength of them. Because the one other gotcha in Cinema 4D is, if you're familiar with using the sub-steps in cloth, the one thing you'll realize is once you up the sub-steps or the accuracy of the simulation, one of the byproducts of that is it makes the simulation stiffer. So that's the same thing if we up the viscosity settings here to say 60 and 60. If we just kind of rewind here and zoom out, there's our emitter. Let's move this down and hit play. You're going to see that almost looks like a water balloon that's kind of blowing up. It's way more viscous. It's moving very slow. The flow is very slow because the viscosity is very high. And that's because we basically amplified the strength of the viscosity and the surface tension because we upped all those iterations so high. So what we need to do is we need to counterbalance how stiff the simulation's getting with those added iterations by offsetting it by bringing in much smaller constraint values. So I'm talking like 0.05 and maybe 0.08 for your viscosity and your surface tension. So we're talking very small values. And now you can see, okay, this is looking a little bit more viscous and liquidy And now we can see if we have that jittering, that popping and locking that was going on. If I zoom in to the particle edge where we were seeing that before, you can see that, okay, it's much more calmed down. And if we turn on the liquid mesh, we'll really get a sense of, is this really popping and locking? And you'd see, no, it's actually very, very smooth, okay? So that is the biggest gotcha of liquid sims. Well, actually the second one, because number one is that, again, it doesn't work at real world scale. So two little gotchas to understand what's going on with the liquid sims. So one thing I want to kind of reiterate about what each of these different type of settings do, this is the flow, okay? And this is how much it's splashing. So if you want something to be a little bit more viscous, but spread out more, what you're gonna do is up the viscosity to maybe 0.1. If you want things to flow a little bit more, you're gonna bring down the surface tension, okay? So let's see what this looks like. So we have a lot more viscous kind of fluid with less surface tension, so we might get a little bit more splashing going on. Or at least the surface, the water surface is gonna go a little bit outwards more. And so you can see kind of what's going on there. Now, another thing I wanna kind of cover is that this is gonna look very lame if the simulation, if the emitter is just staying in the same place. So one thing I recommend you do is either animate the emitter, or if you really just wanna test things out, just go and right click and add a vibrate tag to this, enable the position, and let's just up the Z position and the X, and we'll bring down the frequency to like 0.5. And if we rewind, now we actually get a little bit of variation. If you think about you're pouring some liquid or syrup on a pancake, you're not just gonna, have it and just squeeze it in one place. You want to cover those pancakes, get the surface area there. You're gonna move the bottle of maple syrup around to kind of maximize that area. So this is kind of the same thing. You can see just by adding a vibrate tag to this, we're getting a lot more interesting simulation. Now, this looks like it's just kind of slipping off our object. So let's fix that. And so we can do this two ways. We can go into our collision tags here and up the friction a whole bunch to maybe like 15. We're actually going to get rid of the bounciness there. And then we also have separate settings in the liquefy modifier. We have this friction value right here, and I'm going to up this to say like 40, okay? Another thing we can do is up the damping, and that's just going to have a little bit more energy loss from the particles the higher this damping value is. And so now let's rewind, and hopefully this will make this look a little bit more like a sticky type of fluid versus it just kind of falling right off and slipping right off our objects here. And really you want that friction so you can get that nice kind of buildup. Think of that like liquid chocolate that's on a candy bar in those commercials. You got that nice little kind of ribboning. And so for that kind of thing, what you want to do is you want to think about the size of the emitter and the shape of the emitter. So if you want the ribboning, let's go into a rectangle and just make this particle emitter a little bit thinner. And because we made it smaller, we should have enough of the particles packed together that we should have a nice thin sheet of liquid here. And we have this kind of going back and forth. Actually go to this angle right here. And so you can see that the ribboning isn't happening all that well. And that's because if you want that ribboning, you want those water particles to stick together a little bit more, that's the job of surface tension. So what I've kind of found with the viscosity and the surface tension here is I like to make the surface tension just a tiny bit higher than the viscosity here, but not by too much, okay? So let's rewind and let's hit play again. And so what we should have here is a lot more surface tension. You can also see that this is a pretty thick mesh here as well. So one thing we can do is go to the liquid mesh, try to bring this down. But again, this is based off of the actual particle size. So if I hit Command or Control D, I can go into the liquid's default radius and just make that slight bit smaller. And you can see what's going on there. This is a much thinner little ribbon of, let's just say this is chocolate. And let's actually up the amplitude here so you can get this really moving back and forth. There we go. And so you can see that a combination of the viscosity with the surface tension, we can kind of get some nice string, like a ribbon of nice little chocolate here, which is looking pretty good. And so, depending on what values you choose in the viscosity and the surface tension can totally change the look of your water sim. All right, I apologize. I'm going to interrupt the flow of this liquid tutorial to let you know that if you want to take your Cinema 4D skills to the next level or learn literally any other type of motion design app, we're talking Rive, Unreal Engine, Blender, the list goes on, check out our full course lineup at schoolofmotion.com and learn more about our all access program where you can take any course in our curriculum at any time you want and get feedback from one of our talented teaching assistants who are working industry pros. All Access is perfect for anyone looking to master the fundamentals and beyond. All right, let's dive back into the tutorial. So what I wanted to do is just kind of show you side by side some of the sims and some of the different settings that I put in for both the viscosity and the surface tension. But this kind of gives you, if you look at each of these different values here, how the interplay between more viscosity or more surface tension, or maybe you have more surface tension than viscosity and vice versa, and just how different those sims look. You can see back here in this scene, we're getting this really nice ribboning going on. We can certainly tweak this a lot more. And we're seeing a little bit of some jankiness going on here. And you might be wondering, okay, how do we make this into a nice little render here? You might notice that if you go and you start up the IPR, that all we have here is the actual particles and not the liquid mesh. And that's because this is all running on GPU, and right now it's not exporting the geometry. So if we want to export the geometry so we can actually apply a material to it or whatnot, we're going to change this to on. And then we're also going to export out the normal, okay? Because without the normal, everything's going to look janky. So let's just wait for this geometry to show up here. And so you can see there's the geometry, and that's without the normals. Once we turn the normals on, you can see that sort of smooths everything out. And this is where if we go back into our liquid mesh properties, this is where this smooth normal iterations comes in. So you want to up this, and that'll smooth out the surface pretty nice. And of course you can see these little like pock marks here, and that is again just going to be fixed by upping the influence scale. And if you want to make this thinner, just bring in this surface offset. One other thing to keep in mind is you can go negative in the surface offset here as well. So let's actually turn off the particle group from showing up in our render because we don't want these green particles in there. So we're going to double click on this bottom stoplight here, turn it to red. So this is going to hide the particles from our render view. And we have our resulting mesh that we can go and then apply a material to said liquid mesh object. Okay, so what I want to do at this point is show you what I think is a real-world production scenario where Cinema 4D Liquids actually does an amazing job, and that is, again, with that thick, viscous type of liquid. So I'm going to break down how to create a nice honey sim with even little bubbles inside, how to texture it, how to set up the lighting, and then ultimately how to cache things out so you can go and render this puppy. So here is my default scene. I'm going to provide this to you so you can check it out, but right now I just have a basic emitter, and it's set to a sphere shape, so it's not just a flat disk, it's a full sphere. I have the rate in particle emission at 10,000 per second, and we have our basic default settings in our collider and everything else. So even in my simulation liquid settings, you can see the only thing I changed is the default radius there. So if I hit play, you're going to see we're not going to have anything very viscous at all. And so if we want to up the viscosity and the surface tension and even make the quality a little bit better, we're going to up the iterations here. And remember, by upping the iterations, it's going to make everything a lot stiffer. So again, this is one of the things that you really have to understand is that the higher the quality, the higher the iterations, the stiffer the sim is going to get. So this is looking actually pretty good right now. If we think this is going to be honey, actually this is going to stick a lot more to our surface of our objects. So both in our collision tag and our actual liquefy modifier, we have the friction options. So I'm going to go and crank this up to 40 on the collider tag, and on the liquefy modifier, I'm going to crank up the friction here to, let's just say 10, okay? And so if I rewind, so already you can see this is looking super, super viscous. We're getting some nice drips going on there. But one thing to keep in mind is what each of these values are doing. So if you wanted more, say, surface coverage of this liquid over the surface, we can bring down the surface tension a little bit, as well as maybe bring down the viscosity as well. So I'm going to change those things. You can also up the damping, which is going to bring the particles to a rest faster. And then one thing that we can do as well is adjust the stickiness. So stickiness is like a supercharged type of friction. It's much stronger. And what this allows us to do is have particles actually stick to the surface. So if you dip anything in honey, it's not just all going to fall off. There's going to actually be a thin film of honey left on the object. So to recreate that effect, we're going to up the stickiness value both here in the liquefy modifier and in our collider, because if either of those options have 0, it's going to have 0 stickiness. Okay, so you need to make sure you have values in both the collider and the liquid itself, the liquefy modifier. So I'll up the stickiness here to like 0.5, and you can see I upped the friction here pretty high to 40, and we'll get rid of the bounce. And if we go and let this play out yet again, so I'm going to pause the sim right here and zoom in because I wanted to show this thin film of particles that are now sticking to our object. And so that is a direct result of that stickiness value. So this is going to be a little bit more like honey. We could, of course, up these values if we want even more stickiness. So this is looking good. And I think at this point, we got this really nice drip. Let's go and turn on our liquid mesh. And you can see the settings I dialed in here as well. You can see I have a pretty high smooth iteration in here. So you can see how it's just kind of smoothing everything out. And then normal smooth iterations too. You can see I already turned on the geometry and normal export. So all that stuff is there. You need to make sure you do that before you apply any material to it. And so now let's go and let's apply a honey looking material to this liquid sim or this liquid mesh. So luckily, if we go into our asset browser here and just search for honey and then filter by materials, you can see there is a liquid honey preset material, which does a lot of the heavy lifting for us. I'm going to go and add that to our scene. And then to add this to our liquid object or a mesh, we need to make sure we actually apply it to the thing generating the mesh, which is this liquid mesh right here. So I'm going to go and close out of our asset browser. I already turned off this particle group from render. So if I go and get my Redshift render view and then dock this to the side and fire off this render. And again, you can check out this project file and all of the different post effect settings that I added into this as well. So again, if you don't turn off the particle group from render view, it's going to show up there. So we'll turn that off. And so what we're left with is an unlit scene that looks kind of garbagey. Okay. And so what I wanted to kind of highlight is the fact that, especially if you're working with transparent materials, which if we go into what this liquid honey preset looks like and what it's utilizing, is it's using transmission or transparency, and it's also using a little bit of subsurface scattering. Okay, so when you have a highly reflective object with transmission, how it's going to look is highly dependent on the environment that you have it in. So if you don't have an HDRI, if you don't have any lights, there's nothing to reflect, and it's going to look like this. So I'm going to turn on the HDRI dome light that I have in here, and you can see that. And then I'm going to turn on the background light and then a couple area lights that are off to either side. And you can check out this scene again to see how I positioned the lights. And you can see we got something looking pretty good. We got this really nice rim light on the side there, looking pretty hot, pretty sexy. But this is looking a little bit like caramel right now. And I know some people say caramel. I'm a caramel type of guy. But what we need to realize at this point is, remember, we're not working at real world scale, and materials, especially material presets, have a lot of the values dialed into real world scale. So something like the depth of the transmission needs to be upped for the light to transmit far enough through the mesh that is much thicker than a real world scale value. So if we up this depth to say 35, you're going to see, voila, that allows a lot more light to pass through and illuminate the inside of our object. We can also do the same thing with the subsurface scattering here. Maybe we bring this to say 12, and this is looking a lot nicer. Now, one thing I wanted to point out about any type of gels or anything like that, sometimes you might need to up the IOR or index of refraction. So if you have like hair gel or something like that, upping it to 1.5 is going to be a little bit better. And so I encourage you to look online, just search for what is the IOR value of whatever liquid, say milk or gel, and it will tell you what that IOR value should be. And so I think everything's looking pretty good as far as material wise goes. Now it's time to add in those nice little bubbles, okay? So what we're gonna do for that is we're gonna take the basic emitter and the particle group with the liquefy. We're gonna take all those and command, click, and drag. And what we're gonna do is rename these to, say, the particle emitter bubble and the particle group bubble, and then the liquefy bubble. And what we also need to do is we don't need to actually mesh these particles here. So what we're gonna do is just take that particle group for the bubbles and just put it in the exclude mode for this liquid mesh here. Now, what we're also going to do is we're going to delete the vibrate tag, and we're just going to place this emitter underneath the basic emitter that we already have here. Now, the trick here, let's rewind and let's actually turn off our render view here. The trick here is that we have our emitter that's emitting bubbles on top of the existing emitter, and we don't want bubbles to form on the outside. So what we're going to do is just shrink down the bubble emitter just a little bit, so all the bubbles, all the particles will be emitted inside the particles that are being created by our main emitter here. We also don't need 10,000 bubbles, so we can bring this down to, say, like 30, something like that. And then we also need to clone geometry onto these bubbles. So if I go and I hit play, you are going to see, if I turn off my liquid mesh here, if you want to see what the particles are looking like in a specific group, all you need to do is just select that particle group and you can see those bubble particles highlighted in there, okay? So I would say this is looking pretty good. We got some good bubble coverage here, and I'm gonna go and get a cloner, and then we're gonna clone some spheres onto the object. In what object? Well, we're going to clone onto the particle group bubble. So we want to clone onto the bubble group, not the emitter. If you do the emitter, nothing's going to show up. So make sure you are cloning onto the particle group, okay? And so these spheres are very big. We're going to bring these down to, say, like 1 or maybe 1.5. And then we can randomize the size of these bubbles. Let's just rename this bubble cloner here. And with that cloner selected, we're going to go and grab a random effector, go to the parameters, turn off position, turn on scale, uniform scale. And if we adjust this, you can see we're making the spheres bigger and smaller at the same time there. And so what we can do at this point is turn on our liquid mesh and then fire up our redshift render view. And you can see we have some bubbles inside of our liquid there, but of course this doesn't have any materials on it just yet. So what we're gonna do is command click and drag, and we're going to rename this to bubble, and then we'll apply this to our bubble cloner object here. And so you'll see that update, and you'll notice that the bubbles are not showing up very good at all. And why this is that our IOR needs to change, because if it has the same IOR as the liquid that it's in, that's not going to be physically accurate. So all we need to do is, for the bubbles, change the IOR to 1. And then with that update, you can see how everything looks much more bubbly and realistic, okay? So what we're gonna do is let's turn off the liquid mesh, let's turn off our render view, and let's just let this sim kind of play a little bit here. And the one thing you might notice is that some of the bubbles are kind of hitting the outside or the outside of the surface of our simulation here. So we don't want bubbles to be kind of like poking out, like here's a bubble that's just on the outside of the mesh. So there's one last thing to do to make this work nice, and that is to go into the liquefy modifier of the bubble, and we're going to change the density of those bubbles just slightly higher than the density of our main particle group here that's making the liquid. And with a higher density, it's going to stay within the mesh much better. So if I go and I hit play again, and I'm going to select the particle group bubble so we can see those particles in there, and you can see that it's doing a better job at staying inside the mesh. Now notice there's a little bit of lag once you pause the simulation because just of priority issues, but with this, we should have a lot of the bubbles kind of staying inside a lot better. And if you really want to make sure that things are staying inside, you can just really make the emitter a lot smaller, like so. And so once you get your simulation looking the way that you want, it's time to cache this, so you're not constantly churning through creating these particles each and every time, right? So what we're gonna do is we got 2 particle sims in here, and we're gonna go to both of the particle groups and go to the cache tab. And this is where you can cache the scene, so not just a single object, but any type of particle sim in the scene, and save it out as an Alembic file. So I'm gonna cache this, and it's gonna tell you where do you wanna save this. And you can see I've already done quite a few tests. You can see some of these files are very big, and I'm just gonna name this test, and we'll just let this cache here. All right, so let's play this back. So we got this really nice viscous particle sim. We got our little bubbles on the inside. You can see some of the stickiness results right there. And this is where you just like pause the sim and just check it out at either point, and just remember to put the liquid mesh back on, and there you go. So that's how you get a kind of convincing liquid honey sim with bubbles inside of Cinema 4D. Now this is ready to render with all the particle sims kind of cached here. Again, this is where the Alembic file is, that if you want to bring it into another app or bring it into another file, scale everything down, you can do exactly that. But I want to leave you with one last tip for a little gotcha that you might run into. And that is if you want a very thin but viscous kind of liquid coating on an object. Like I got some Japanese mochi dango here, got some like teriyaki sauce on top, and you can see all of this tearing happening. You can see that what we have going on here is looking really good. We got our liquefy here. You can see the values that I kind of plugged in here. So a little bit more surface tension than viscosity. So it's a little bit more runny, and some high friction, high stickiness values as well. But we have all these gaps. Now, sometimes when you are running a simulation, no matter what settings you dial in here or the liquid mesh, you're gonna get these holes. And the only solution for this is to simply add more particles to your sim. So what I'm gonna do is go to my basic emitter. You can see I'm at 10,000. Let's triple this and go to 30,000, and let's run that back yet again. So didn't change anything really much at all, just added a lot more particles, and you can see we no longer have those little holes. Now this is a little bit thicker of a sim, so we can go in and maybe bring the default radius down to like 1.2. And if we have enough particles being generated, it shouldn't matter much because we will not have those holes because we have so many particles filling in those gaps that we no longer have them. So sometimes the simple solution to having a very thin liquid is to just make sure you have enough particles being simulated that you can then mesh so you don't have those gaps. And so now we have this nice little teriyaki soy sauce liquid, syrupy liquid on top of our Japanese dango. And I don't know about you, but I'm getting pretty hungry after all these sims. Well, that, my friend, brings us to the end. So to answer the question I had off the top, is Cinema 4D Fluids any good? Well, I think for what it can do, it's pretty powerful. It's easy to use. Mind you, this is version 1, so comparing it to X Particles or Houdini is just not fair, but I do think that this new liquid sim system is, again, perfect for more of these MoGraphy setups, and it has loads of control. So what do you think? Leave a comment on your experience with Cinema 4D Liquids. Has it gone swimmingly, or have you been riding some choppy waters there? Now, if you have any questions about liquid sims at all, drop them below and I'll do my very best to help out and answer all those questions. And be sure to like and subscribe if you like what we're doing here on this channel. If you don't, there's liquid sims that are gonna come out of my eyeballs. As always, thanks so much for watching, and I'll catch you in the next tutorial. Peace.